Abstract. Sentiment analysis or opinion mining is one of the major tasks of NLP. Sentiment analysis has gained much attention in recent years. In this paper, we aim to tackle the problem of sentiment polarity categorization, which is one of the fundamental problems of sentiment analysis. A general process for sentiment polarity categorization is proposed with detailed process descriptions. Data used in the study are online product reviews collected from Amazon.com. Experiments for both sentence level categorization and review level categorizations are performed with promising outcomes. At last, we have also given insight into our future work on sentiment analysis. Introduction to sentiment analysis. Sentiment is an attitude, thought, or judgment prompted by feeling. Sentiment analysis, which is also known as opinion mining, studies people's sentiments towards certain entities. From a user's perspective, people are able to post their own content through various social media such as forums, microblogs, or online social networking sites. From a researcher's perspective, many social media sites release their application programming interface, prompting data collection and analysis by researchers and developers. For instance, Twitter currently has three different versions of APIs available, namely the REST API, the Search API, and the Streaming API. In the REST API, developers are able to gather status data and user information. The Search API allows developer to query specific Twitter content, whereas the Streaming API is able to collect Twitter content in real time. Moreover, developers can mix those APIs to create their own application. Hence, sentiment analysis seems having a strong fundament with the support of massive online data. Drawbacks of available data. The first flaw is that since people can freely post their own content, the quality of their opinions cannot be guaranteed. The second flaw is that ground truth of such online data is not always available. Overcoming drawbacks. The rating is based on a star scale system where the highest rating has 5 stars and the lowest rating has only 1 star. Proposed model. The first phase of the proposed model is data preprocessing, where data is firstly reviewed and then after reviewing the data, sentiment from the data is extracted and with the help of a part from grammar, parts of speech, we tag the data with parts of speech present in it. The second phase of the proposed model identifies sentiment and computes the sentiment score of the data, and with the help of extracted feature from the sentiment, a vector is generated which contains all the feature that is extracted from the data. Third phase. The third phase categorizes the sentiment data and interprets the result. Literature review. One fundamental problem in sentiment analysis is categorization of sentiment polarity. Given a piece of written text, the problem is to categorize the text into one specific sentiment polarity, positive or negative or neutral. Based on the scope of the text, there are three levels of sentiment polarity categorization, namely the document level, the sentence level, and the entity and aspect level. The document level concerns whether a document as a whole expresses negative or positive sentiment, while the sentence level deals with each sentence sentiment categorization. Where here we can see in the slide the literature where Hugh and Liu summarize a list of positive words and a list of negative words, respectively based on customers' review. For the feature selection, Fang and Lee suggested to remove objective sentences by extracting subjective ones. Gan et al. Selected 6,799 tokens based on Twitter data, where each token is assigned a sentiment score, namely TSI, where the TSI stands for Total Sentiment Index, featuring itself as a positive or a negative token. In research design and methodology in data collection, data used in this paper is a set of product reviews collected from Amazon. From February to April 2014, it collected in total over 5.1 million of product reviews in which the products belong to four major categories: beauty, book, electronic, and home. Each review includes the following information: reviewer ID, product ID, rating, time of the review, helpfulness, review text. Every rating is based on a 5-star scale, resulting all the ratings to be ranged from 1 star to 5 star with no existence of a half star or quarter star. Sentiment, sentences, extraction, and POS tagging, where the POS is part of speech. It is suggested by Fang and Lee that all objective content should be removed for sentiment analysis. Instead of removing objective content, in our study, all subjective content was extracted for future analysis. The subjective content consists of all sentiment sentences. A sentiment sentence is the one that contains at least one positive or negative word. All of the sentences were firstly tokenized into separate English words. Negative phrases identification. Words such as adjectives and verbs are able to convey opposite sentiment with the help of negative prefixes. For instance, consider the following sentence that was found in an electronic devices review. A built-in speaker also has its uses, but so far nothing revolutionary. The word revolutionary is a positive word. However, the phrase nothing revolutionary gives more or less negative feelings. Therefore, it is crucial to identify such phrases. In this work, there are two types of phrases that have been identified, namely negation of adjective and negation of verb. Sentiment score computation for sentiment tokens. A sentiment token is a word or a phrase that conveys sentiment. Given those sentiment words proposed in a word token consist of a positive, negative word and its part of speech tag. Where given a token T, the formula for T's sentiment score computation is given as occurrence T is T's number of occurrence in I star reviews, where I is equal to 1 to 5, where in a data set it is not balanced, which indicates that different number of reviews were collected for each star level.
The process of sentiment polarity categorization is twofold: sentence level categorization, review level categorization. Given a sentence, the goal of sentence level categorization is to classify it as a positive or negative in terms of sentiment that conveys, indicating the positiveness and negativeness of a given sentence. However, the ground truth tag becomes a really challenging problem due to amount of data we have. Since manual tagging each sentence is infeasible, a machine tagging approach is adapted as a solution. The approach implements a bag of word model that simply counts the appearances of positive and negative word for every sentence. If there are more positive tokens in negative ones, the sentence will be tagged as positive and vice versa. Sentiment tokens and sentiment scores are information extracted from original dataset. There are also known as features, which will be used for sentiment categorization. In order to train the classifiers, each entry for training data needs to be transformed to a vector that contains these features, namely a feature vector. One challenge is to control each vector dimensionality. The challenge is actually twofold. Firstly, a vector should not contain the abundant amount of features or values of a features because the curse of dimensionality. Secondly, each vector should have the same number of dimensions in order to fit the classifier. Since we only concern each sentiment token's appearance inside a sentence or a review to overcome the challenge, two binary strings are used to represent each token's appearance. For instance, if the ith word face token appears, the word string ith bit will be flipped to 0 to 1. Finally, instead of directly saving the flipped strings into a feature vector, a hash value of each string is computed using Python's built-in hash function and is saved. Hence, a sentence level feature vector has total 4 elements, two hash values computed based on flipped binary strings, and an average sentiment score and a ground truth label. Evaluation method. Performance of each classification model is estimated based on its average F1 formula, which is given in the formula, where Pi is precision of ith class, Ri is recall of ith class, and N is the number of classes. Pi and Ri are evaluated using 10-fold cross validation. A 10-fold cross validation is applied as follows. A dataset is partitioned into 10 equal subsets, each of which consists of 10 positive class vectors and 10 negative class vectors. Of the 10 subsets, a single subset is retained as validation data for testing the classification model, and remaining 9 subsets are used for training data. The cross-validation process is then repeated 10 times, which each of the 10 subsets use data exactly as validation data. Sentence level categorization results based on manually labeled sentences. 200 feature vectors are formed based on 200 manually labeled sentences. As a result, the classification model shows the same level of performance based on the reference scores, where three scores are all of same value 0.85. With the help of ROC curve that is given in the figure, it is clear to see that all three models perform quite well for testing data and have high posterior probability. As for probability getting lower, the new Bayesian theorem outperforms SVM classifier with a large area under the curve. In general, the random forest model performs the best. Sentence level categorization result based on machine label sentences. Four subsets are obtained from complete set with subset A containing 200 vectors, subset B containing 2000 vectors, and subset C containing 20,000 vectors, subset D containing 200,000 vectors respectively. While the models are getting more training data, their one scores are all increasing. The SVM model takes most significant enhancement from 0.61 to 0.94 as its training data increases from 180 to 1.8 million. The model outperforms new Bayesian model and becomes second best classifier on subset C and the full set. Random forest model again performs the best for dataset on all scores. View level categorization. 3 million feature vectors are formed for categorization. Vectors generated from reviews that have at least 4-star rating are labeled as positive, while vectors labeled as negative are generated from 1-star and 2-star reviews. 3-star reviews are used to prepare neutral class vector. As a result, this complete set of vectors are uniformly labeled into three classes: positive, neutral, and negative. The figure shows F1 score obtained on different size of vector. It can be clearly observed that both SVM model and new Bayesian model are identical in terms of performance. Both models are generally superior to the random forest model on all vector sets. However, neither of the model can reach the same level of performance when they are used for sentence level categorization due to their relative low performance of neutral class. Conclusion: the sentiment analysis or opinion mining is a field of study that analyzes people's sentiments, attitudes, or emotion towards certain entities. This paper tackles a fundamental problem of sentiment analysis, sentiment polarity categorization. Online product reviews from Amazon.com are selected as data used for this study. A sentiment polarity categorization process has been proposed along with detailed description of each steps. Experiment for both sentence level categorization and review level categorization have been performed.